For tonight's homework, you're going to be completing some SBAC review problems. It's best if you can really try to complete them yourself first and give yourself a chance to think about what kinds of strategies you would use to address each type of problem, because testing comes up next week, and so these are problems that are similar to what you might see next week. A representative sample of 50 students from a high school is surveyed. Each student is asked what science course he or she is taking. Choose true or false to indicate whether each statement is valid based on the survey results. So one of the topics you guys haven't seen a whole lot of yet is talking about the concept of a representative sample. And a representative sample just means that it's a good sample that we tried to come up with a group of people that would reflect the ideas of the people we want to know about. There's also this word here, valid, right, which would mean true. And so again, we want to know if each statement is accurate, right? So looking first here, based on the representative sample, twice as many students are taking health science than are taking physics. Well, looking at health science, I can see 12 people are taking health science, 6 people are taking physics. So twice as many are taking health science than are taking physics. That looks accurate to me because I'd have to multiply physics by 2 to make health science. So this is true. 20% of the students at the high school are taking chemistry. So looking at what's there, it's 10 students out of 50 total, and I need to convert that into a percent. And so one way to do that is with a proportion. So 50 times 2 would be 100, 1 times 2 would be 20, and 20 out of 100 is equal to 20%. So 20% are taking chemistry. In a group of 25 students, it is expected that 4 of the students are taking earth science. Well, looking at earth science, I see 4, but I remember that the sample size is out of 50. So I would expect 4 out of 50 to take earth science instead of 4 out of 25. This will be false. In a group of 150 students, it's expected that 18 of the students are taking physics. So again, I'm going to try to set up a proportion. So 6 out of 50 is the current number that are taking physics. And if I scale this up to 150, that's going to be times 3, and I would get 18. So yes, I would expect 18 to be taking physics. This is true. The spinner has 8 equal-sized sections, each labeled 1, 2, 3, or 4. The arrow on the spinner is spun. Match the outcomes landing on a 1, 2, 3, or 4 to the category that correctly describes the probability of the outcome. One thing we might want to do before we start as well is to actually come up with each probability. So for example, I see there's 8 sections, so my probability of getting a 1 is 1 in 8. My probability of getting a 2 would be 1, 2, 3, stopping right there, 1, 2, 3, 3 out of 8. My probability of getting a 3 is 2 sections here, so 2 out of 8, or 1/4. And my chances of getting a 4, P4, are also 2 out of 8, or 1/4. So again, having those ready to go can kind of help me make some comparisons. So is the probability of landing on a 1 less than 1/3 or greater than 1/3? You might even be able to kind of envision what this piece would look like. If it's going to be a third, right, it needs to be something a little bit more like this part of our circle, right? It needs to be about a third of the circle, and that's definitely less. So landing on a 1 is going to be in the less than 1/3 category. Landing on a 2. Well, this one's kind of interesting because landing on a 2 is 3 sections here. It's 3 out of 8. But how does that compare to 1/3? How do you remember comparing fractions? So I want to know which one's bigger, 3 out of 8 or 1 out of 3, or are they the same? One way to do this is to find a common denominator. So for example, 3 and 8 both go into 24. So let's convert them into 24ths. So 8 times 3 is 24, 3 times 3 is 9. 3 times 8 is 24, 1 times 8 is 8. So which one's bigger, 8 24ths or 9 24ths? 9 24ths would be bigger. So that means that 3/8 is greater than 1/3. So landing on a 2 goes in the greater than 1/3 column. What about landing on a 3? Well, landing on a 3 is equal to 2 out of 8, 2/8. You might also notice that 2/8 is 1/4. You might also know that 1/4 is equal to about 25, or is equal to 25%. And you might know, for example, that 1/3 is like 33%. So that's probably a clue for you in terms of thinking about how landing on a 3 is actually less than 1/3. And landing on a 4 is the same as landing on a 3. So we're also going to put that in the less than 1/3 column. There's a whole lot of different ways you could have approached this problem, so definitely feel free to be ready to share some strategies that you came up with to make sense of it. Consider the equation. So this is my whole equation over here. Identify two expressions that are equivalent to W in the shaded section. Well, one way to help me start making some sense of this would be to do some distributing. And so, for example, I can see that 3 times 4v plus 1 is equivalent to 12v, right? Because 3 times 4v is 12v, plus 3, minus, over here I have 3 times 2v plus 3. And again, let's actually put that minus here because I want to distribute the negative here. So negative 3 times 2v is going to be negative 6v. And then I have negative 3 plus, or times positive 3 is going to be negative 9. And so now I can combine these guys. So I'm looking here, I can get a total of 12v minus 6v is 6v, and 3 minus 9 is minus 6. So this whole side of the equation could simplify to 6v minus 6. And over here, I need to think about what this could be. So let's try distributing this piece right here first. So 2 times v minus 6. Let's do 2 times v, which would make 2v, and 2 times negative 7, which would be negative 14. So over here I have 2v minus 14 plus w. So I have to think about what could I add here, what could fit here as w that would cause it to be equivalent. So let's play with some different things. If I added 4v, I would get 6v, right? Because I would be 4v plus 2v is 6v. And then if I added 8 plus negative 14, I would get negative 6. So actually, if you look at this very first one here, 4v plus 8, that's going to cause me to get an equivalent answer. And again, just to kind of prove it here, 2v minus 14 plus, I'm going to substitute this here, 2v plus 8. Or I'm sorry, 4v plus 8. And 2v plus 4v is 6v. Negative 14 plus 8 is negative 6. So again, you're noticing that I get this piece here, which is equivalent to what this simplified to right here, right? And that's going to work for us. Let's try another one, negative v plus 9. Well, if I added negative v to 2v, I would get v. So I can already see that there's a problem there because I need to get 6v. Not going to work. What if I did 2v plus 8v? That would give me 10v. Not going to work. What if I distribute some of these guys out and see what comes next? So here, 6 times v is 6v. 6 times negative 1 is negative 6. So let's try that. 6v plus 2v would make 8v. Not going to work. Let's try this one over here. So negative 1 times v is negative 1v. Negative 1 times negative 9 is positive 9. So now envision that I add negative v to 2v. What would I get? I'd have just v. So unfortunately, that's not going to work for me. Going to the next row, I've got 4v minus 28. So again, I can combine 4v plus 2v, and that would give me my 6v here. And then I have minus 28, and I'm combining that with minus 14. Well, if I think about if I have negative 14 and I subtract 28, I'm going even further into the negative. I'm going to get down to negative 42. So unfortunately, that's not going to work. 6v plus 2v is going to give me 8v. Not going to work. Let's do some distributing again. So 4 times v is 4v, plus 4 times 2 is 8. So 4v plus 2v would give me 6v. That's a good start. And then negative 14 plus 8 would give me negative 6, or minus 6. So this combination here is going to work for me. 4 times v plus 2. Let's try the last ones just to make sure we can see if any others would work. So this would be 4v, and then 4 times minus 7 would be negative 28. And so 4v minus 28, I could actually see that didn't work over here either, so I know that's not going to work. And then over here, 4 times 2v is 8v. 4 times negative 5 is negative 20. And I actually recognize that up here as well. 8v minus 20 didn't work before. It's still not going to work. So that's one way to kind of work through this problem. Again, you might have found some other ways, but this is a great problem to think about combining like terms and a distributive property. And again, if you're having trouble with the distributive property, this is a great topic to look up because you're going to use that a lot in 8th grade and beyond. So that's the end of your SBAC review for today. Hopefully you can come to class tomorrow ready to talk about the problems that you had correct and reflect on what you still need help with.